Algebra 1 1.8 deals with introduction to functions. So we're going to deal with functions. You should have your vocabulary by now because we're going to be using a lot of those words. I'm going to assume you understand. So basically what a function is it relates an input and an output. And you've seen input and output before. It's just another term that they use for your x and your y. Your input is called your x, which is also called domain. So just keep that. You hear input, domain, think x. Your output is your y, and it's also called a range. So your your output and range both think y. So basically we're dealing with our x and y variables, and a function relates both letters. So you have both letters in your equation because you're dealing with equations usually with just one letter. Now we're dealing it with x and y. Okay? So it says for every input there is only one output. So that means it's only a function if, when I put x in an equation, so just imagine there's an equation, I put 0 in, I get 5, 1, I get 10, 2, I get 15, 2, I get 20. What that's saying is, let's say my equation is y equals 12x plus 3. And I put a 2 in there, and I get a number, right? 2 times 12 is 24, plus 3 is 27, right? If I put a 2 in there again, I should get, what? A 27, the same number, okay? So it's a function only if that's correct. In this case, if I have a table and I have the same exact number, so same input, but I get different outputs, and that means if I put a 2 in there again, somehow it became a different number. So this is not a function. It doesn't mean I can't have repeat numbers. As you can see here, 5 and 5, y can have repeat numbers, but if x has a repeat number, okay, it has to be the same number. So, sorry, this is supposed to be 10 up here, just so I can illustrate. This is supposed to be 5. So 0 can equal 10, 1 equals 5, 2 equals 5. It's the same thing. So it doesn't matter if y is double, it doesn't matter if there's x double, it's just for every input there has to be only one value for the output. So I can't have two different numbers right here. Okay, I put 2 in an equation, I get 15, 2 in again, and 20, it doesn't make any sense. So this is not a function, this is a function. Right? So go ahead and pause, write that down, and I have one more board, and you're all set. So here in this question, it's saying, you bike 4 miles and decide to ride 2.5 miles at 6 miles per hour. Okay? So I'm creating an equation. My equation is y is going to tell me, okay, how many miles I've biked total. Okay, I've started with 4. Right? And now I'm going to go into, I'm going to add I'm going to add for every 6 miles per hour, how much time, let's say x. Okay, so y would be total miles, and my x would represent my time, right? So however much time I have. So in this case, I did 6 miles per hour, right? And I did 2.5 more. Sorry, not more miles. This is more hours. So y equals 4 plus 6x times 2, and x is my time. So basically, if I were to write, let's say I was supposed to do 3 more hours, and I do 3 times 6, which is 18, plus 4, which then would give me 22. So that means I'd bike a total of 22 miles. In this case, let's say I just did 2.5 more miles. Well, then I multiply it by the 6 to get 4. You see how the equation? This is my original, so no matter what, I've already biked 4 miles. And however many hours I do for every hour, because it's 6 miles per hour, Okay, I've multiplied the hours by 6 because every hour is 6. And I add them together and it gives me my y, which is my final and my total miles. Now, if you're not quite sure if you can do those equations on your own, don't worry, we'll take it slowly. But as long as you understand how the equation is established, then you should be all set. Now, this is a table, right? And it wants me to create a table for times between 0 to 25 hours. So if I had stopped somewhere, not 25, 2.5. So this will be my time, okay? So this would be my x. This is my equation, and your book doesn't have this. I think it's great to have this. This is where I show my work. Okay? This is important for you to have because I'm expecting you to have it even if your book doesn't have it. And the last thing is miles, my total miles. And this is my y. So here's how it works. I have 0 to 2, so I'm going to, 2.5, so I'm going to put 0 hours. I'm going to do 0.5 hours, so half an hour. I'm going to do 1 hour. I'm going to do 1.5. And then I'm going to do 2. And I'm going to do 2.5. And what I'm going to do is I'm going to take this, I'm going to put it in for x, and then I'm going to solve, right, for y. So this is going to be y equals 4 plus 6 times 0. 6 times 0 is 0, so 4 plus 0, which would give me 4. So then my total miles is 4. See how that works? Okay, I'm going to try a different color. The next one is 0.5, so 4 plus 6 times 0.5 would be 4 plus 3, which would be 7. The next one would be 4 plus 6 times 1. It would be 4 plus 6, which give me 10. This would be 4 plus 6 times 1.5, so that's 1.5 is 6 plus 3, which is 9, so 4 plus 9, which give me 13. The next one is 4 plus 6 times 2, which is 4 plus 12, which is 16. And my last one is 4 plus 6 times 2.5, so 4 plus 15, which would give me 19. So again, this is a new one, but you see how it just shows all the work so that I can see. And this is my input, and this is my output. Alright, my x and my y. And the last one asks, does it justify a function? So do I have any repeats here? No. And I have no repeats. Because a function, I just check the repeats. If there is a repeat, I have to make sure that the y gives me the same exact number. So in this case, it's yes for every output, so for every x, input is my x. There is only one output. Basically, that's saying for every x, there's only one y. And that's why it is a function. So go ahead and pause, write this down, page 51 numbers page 51 number 4, and I'll see you in class.